Okay, this will be my second video on with an example of graphing a function using transformations, and we're going to be doing this square root function. And to get started, I want to identify the most basic square root function, and we'll call that the parent of this guy. So the parent of this function is y equals the square root of x, the most basic square root function. Okay, and we'll come back to that momentarily. Now what we have to do is address all the stuff that's not the square root of x, right? The 1/2, the negative, the plus 4. Those are what we call transformations. So I'm going to separately list x transformations and y transformations. They affect the graph in different ways. X transformations affect the graph in the x direction, meaning left and right, and y transformations affect the graph in the vertical direction, meaning up and down. To start with my x transformations, you go inside the parent function, the square root in this case. So I go inside my square root. That's where x lives, right? That's where my input lives. And I extract that yellow thing that I've got. Everything that's underneath my square root I need to extract. And to determine my x transformations, I treat this expression like it's part of an equation that I'm trying to solve. So like it equals any number. It doesn't matter what number, because that's not important for the transformations part. What's important is, how do we solve for x? How to solve this equation. How do you get x by itself? Well, the first thing you do is you subtract 4 from both sides. That is your first x transformation. So let me write that. Subtract 4. Then, after you do that, you've got negative x equals some number that's irrelevant again. What's relevant, though, is how do you get x by itself? So you divide both sides by -1. That's my second x transformation. Divide by -1. And finally, x is by itself. So we're done. Those are my x transformations. Now I like to make a point here, and since these are x transformations, I like to say these are the things you do to x. So I like to say subtract 4 from x and divide x by -1. I think that's important to keep things straight later on when you're doing so many other things. Those are my x transformations, and I have to do them in this order. The order that I solved for x is the order that I do my transformations. Okay, next, my y transformations. I only have one. It's what's happening to this parent function, to the square root, and what's happening is I'm multiplying by 1/2. Y transformations are just what you see is what you get. So I'm multiplying by 1/2, so I simply write multiply by 1/2, and that's my y transformation. But it's a y transformation, so I like to emphasize I do this to y. So I'm going to say multiply y by 1/2. Let me make that look a little neater here. Hopefully. Multiply y by 1/2, and that is my only y transformation. So I'm going to take this function, and I'm going to apply 1, 2, 3 transformations to it. And as far as the order of these three, the x transformations are completely independent from the y transformations, so you can mix those up if you want to, but you better do your x transformations, since there's more than one, you better do those in the order you see. Okay? So I'm going to work and do my x transformations, both of them first, and then I'll do my y transformation at the end. So what I need is, I'm talking about what I do to x here and what I do to y here, but I don't have any x's and y's. What I need to do is create an xy table from this equation that are going to give me ordered pairs. Now, since this is a square root function, I can only plug in for x numbers 0 or bigger. So the first x value I'll plug in is 0, and the square root of 0 is 0. So that's my y value. And I'm going to sort of, that's kind of the origin, that's a very specific point on the graph, so I'm going to follow that point. I'll highlight it in blue every time we do something to it, okay? So we can keep an eye on it. Then another x value that I might want to plug in, bigger than 0 of course, might be 1 or 4 or 9, and I'm only going to plot 3 points. So let me plot 4 and 9, and the square root of 4 is 2, the square root of 9 is 3. So roughly this graph looks like this. It's in the first quadrant. 0, 0 is our reference point, so that's going to happen here. 4, 2 is over here, and 9, 3 is over here, and you should be familiar with this shape. It sort of starts to flatten out as it moves to the right. It's not a straight line though. Okay, so that's a graph of the parent function, and I only have 3 ordered pairs. You could do as many as you want here, and you could make this graph as precise as you want. But since I'm going to have a graph for each transformation, I'm going to give a rough sketch for each, and at the very end I'll give a very precise graph of my function. Okay, so now I've got my parent, that's taken care of. Now I need to start knocking out the transformations. So I'm going to first subtract 4 from x. What that means is go to every x value here and subtract 4. And I get a new table that I'll write down here. X, y. 0 minus 4 is negative 4. 4 minus 4 is 0. 9 minus 4 is 5. Those are my x values, and my y values did not change. My reference point now is negative 4, 0. So if I were to plot these points, which I'm not going to do precisely because I'm just getting a rough idea, when you subtract 4 from x, all that does is move your graph left 4 units. So my graph now, instead of at 0, 0, it's at negative 4, 0 with the same shape, pointing in the same direction. My reference point is here now. So I've got my first transformation done. Second, I need to divide x by negative 1. So I go to my x column and I divide all of these by negative 1. And I get a new xy table once again. The x values are going to change, the y values will not. So on the y I'll still have 0, 2, and 3. But my x's are going to change signs to give me 4, 0, negative 5. And 4, 0 is now my reference point. So what happens to the graph here is negative 4, 0 became positive 4, 0. 5, 3 becomes negative 5, 3. So my graph reverses direction something like this. 4, 0 is over here, negative 5, 3 is over here. So every point jumps over the y-axis. This is what we call a reflection over the y-axis. It's a reflection horizontally, left to right. Okay? So I've got my second transformation out of the way. Lastly, I need to divide or multiply y by half. So I'll put times 1/2 by each of these y values. And I'll get yet another xy table. So we'll maybe put it over here. So I get x, y. My x values don't change, so I still have 4, 0, negative 5. 0 times 1/2 is 0. 2 times 1/2 is 1. 3 times 1/2, if you want a decimal so you can plot it easier, is 1/2. And my reference point did not change, okay? So don't let that fool you into thinking the graph doesn't change. The reference point is still right here at 4, 0. But 0, 2 became 0, 1. And negative 5, 3 became negative 5, 1/2. What happens is the graph is going to be smashed towards the x-axis. It's going to be compressed vertically, shrink vertically. So our graph is going to be closer down to the x-axis. Same shape, just smushed down. And this is what we call a vertical, because it's happening up and down, a vertical shrink, because it was smushed by a factor of 1/2. And this is our graph. Okay, so this is our final graph. I just need to make it look better by putting it on a cleaner coordinate plane. So let me create some space here. And we'll transfer this onto a coordinate plane with labels and where we can be more precise. So now I've got my new improved coordinate plane, and I'll plot these 3 points with this shape. So 4, 0 is here, 0, 1 is here, and negative 5, 1/2 is here. It's not a straight line, it's a curve, it's a square root function, just really flat, and looks something like this. So this graph and this graph are the same thing. This one's just more precise. And this is, let me move this down really quickly. This is the graph of that original function. if you remember, f of x equals 1/2 times the square root of negative x, what was it, plus 4. And so if you want, you can check any of the three ordered pairs we used. For example, -5, 1.5, that's an x and a y value. You could plug those in for x and for y, which is f of x, and you should get a true statement to check that this point should be on this function graph. All right, so that's how you graph with function transformations. Start with the most basic function you can, look at everything else as a transformation, and apply the transformations to your basic function. The cool thing about transformations is they work the same on every single function, so you don't have to memorize how to graph various types of functions. You can apply the transformations.